Firstly, good morning to one and all. The reason behind starting this channel is to avoid fearness of mathematics. I'm starting engineering mathematics channel. Please support me with 1 like, 1 subscription and number of shares. Today, I'm starting the topic first unit sequence series mean value theorem. This is the first topic I'm started today. Maybe exam was soon, so I'm started previous question papers, questions with solutions. This is the topic sequence series and mean value theorems. Sequence series, there are previous questions, 5 questions. There are some topics. First one is limit comparison test. Second one was ratio test, Cauchy's test, nth root test, integral test, and also alternate series Leibniz test. There are seven. There is the main problem is finding which type of sum given in our question paper to find. In limit comparison test, the given sum is with the numerator denominator. Numerator is smaller than the denominator. Denominator is big than numerator. First one. Second one, given sum is rationalized in the form rationalizing. That one given here. This sum is rationalized with the plus of this one. Second model. Third model was given in sines, tans, causes. It goes under limit comparison test. The first sum is given in limit comparison test. First we will solve these sum. First sum. Given summation 2 through n cube plus 1 minus n. Let we will take as un equal to root cube the root n cube plus 1 minus n. We will written it as n cube plus 1 whole power 1 by 3 minus n. Then we will take common n cube. With n cube we have whole power 1 by 3. Here we take 1 by 3. Then 1 plus here and minus n is common here. Next here 3 and 3 cancel. N into 1 plus 1 by n cube whole power 1 by 3 minus n. Here n is common from all. One plus 1 by n cube whole power 1 by 3 minus 1. Here it is of the form 1 plus x whole power n. There is some formula for this. 1 plus nx by 1 factorial plus n into n minus 1 by 2 factorial into x square plus and so on. Here x equal to 1 by n cube, that equal to n into 1 plus here n is 1 by 3 power n equal to 1 by 3. 1 by 3 into here x is 1 by n cube by 1 factorial plus n means 1 by 3 into 1 by 3 minus 1 by 2 factorial into x square. Here x square is 1 by n cube whole square plus and so on. Here minus 1 is there. Then n into 1 by 3 here, 1 factorial means 1. So 1 by n cube is here. Plus 1 by 3 into, taking LCM, 3 minus 1 minus 2 by 3. By 2 factorial means 2 into 1. It means 2 ones are 2. Into 1 by n power 6. 3 to 6. Plus and so on. Here minus 1 is there. Then n into 1 plus 1 by 3n cube minus, plus into minus, minus. Here it presents 2 by 1. We take it reverse. It comes as 2 by 3, 1 by 2. 2 to cancel. There is 1 by n power 6. Plus and so on. Here minus 1 is present. Then 1 plus 1 by 3n cube minus 1 by 3 is 9 and power 6 plus and so on. Here minus 1 is present. Then finally we get 1 by 3n square minus 1 by 9n power 5. Here step is taking n inside, n plus 1 by n by 3n cube minus 9 by n power 6 plus and so on up to minus n. Here cube, this one cancel. Here n is cancel. Then we get here plus n, in the last minus 1 was cancelled. Then we get n 1 by 3n square minus 1 by 9 n power 5 plus and so on. Then we know that given is limit comparison test. I am telling you one point, that is rationalize it. Given sum is in the form rationalize. Then the sum is the limit comparison test. Then we will take Vn, let Vn equal to 1 by n square. Here we compare with one by n power p, 1 by n square. P equal to 2 we get. 2 is greater than 1. 2 is greater than 1. Then here 2 is greater than 1. It means the given one is Vn, summation Vn is convergent. It is of form AS, auxiliary series. So it is if P greater than 2 greater than 1, so then Vn is convergent. Then by limit comparison test, limit n tends to infinity, Un by Vn equal to limit n tends to infinity. We required Un is, this is the Un, 1 by 3n square minus 1 by 9 n power 5 plus and so on. Then divided by, we take Bn as 1 by n square. We take it outside, gets n square by 1. Then 1 by 3n square minus 9n power 5 plus and so on. Limit n tends to infinity. That equal to n square will cancel in the both. Limit n tends to infinity. 1 by 3 we get minus 9 by n cube plus and so on. We get it as 1 by 3 taking the limit minus 9 by 1 by 9 into infinity means infinity. Then we require the answer 1 by 3. That is not equal to 0. Therefore, summation un is convergent. Here, give required Bn value is P is greater than 1. It means 1 by np means in the form of auxiliary series. In auxiliary series there are 2 points, that is P greater than 1, P less than 1. Here it is convergent. It is divergent. So required Vn is convergent, then the Un is also convergent. First sum is completed, it is of the form limit comparison test. Then second one is, it was in ratio test. How to say is, ratio test is of the form n values. Here all are n values. Then given sum is ratio test. Next we'll start second solution. The second sum is given summation n factorial by n power n. This was in the form of ratio test. By knowing in the sum there are with n. So we will take first, let un equal to summation of, we didn't write summation, we take n factorial by n power n. Then we take un plus 1, that equal to n plus 1 factorial by n plus 1 whole power n plus 1. For this we take un by un plus 1, that equal to un means n factorial by n power n whole divided by n plus 1 whole factorial by n plus 1 whole power n plus 1. Then that equal to n factorial by n power n into n plus 1 whole power n plus 1 by n plus 1 whole factorial. If the divider is taken to numerator, denominator is taken to numerator, it will be reversed. Then that equal to n factorial divided by n power n, that into n plus 1. Here we write it as n plus 1 into n plus 1 whole power n. It is of the form x power a plus b, that equal to x power a into x power b. This is of the form. Then we will divide it as like. Here bases are equal, powers should be added. Then n plus 1, it will be expanding n plus 1 into n factorial. Here n factorial is cancelled, then n plus 1 cancelled, that equal to n plus 1 whole power n by n power n, that equal to, we will write as n plus 1 by n whole power n, that equal to, then we will write as n by n plus 1 by n. that equal to n, that equal to 1 plus 1 by n whole power n. By ratio test, we have some formula. Limit n tends to infinity, un by un plus 1, that equal to, here this is the required value for un by un plus 1, that equal to 1 plus 1 by n whole power n. Here we have some formula. That is 1 plus 1 by n whole power n equal to e. Limit n tends to infinity. So here write as e. E is greater than 1. By ratio test, the summation un is converges. Hence, ratio test verified. This is the required solution. It is converges. Next, we will take the third sum. Here also it is of the form n. Also the third sum is also ratio test. Then we will take solution of this third one. Solution. First we will write given one summation minus 1 whole power n by n plus 1 x power n plus 1. Let un equal to minus 1 whole power n by n plus 1 x power n plus 1. Then un plus 1 minus 1 whole power n plus 1 by n plus 1 plus 1 x power n plus 1 plus 1, that equal to minus 1 whole power n plus 1 by n plus 2 x power n plus 2. Then un by un plus 1, that equal to, here we have un minus 1 whole power n by n plus 1 x power n plus 1 divided by minus 1 whole power n plus 1 by n plus 2 into x power n plus 2. Here the denominator becomes reverse. In the numerator, x power n plus 1 into n plus 2 by minus 1 whole power n plus 1 x power n plus 2, that equal to minus 1 whole power n x power n plus 1 divided by n plus 1 into n plus 2 minus 1 whole power n plus 1. We will take it to numerator, then minus n minus 2. Then the base equal powers should be added. Minus 1 whole power n x power n plus 1 minus n minus 2 divided by n plus 1 into minus 1 whole power n plus 1. Here into n plus 2. Here n and both cancelled. Then minus 1 whole power n x power 2 minus 1, it means minus 1 by n plus 1 into, we take it as then minus n minus 1 into n plus 2 divided by, here bases are equal, powers should be added, n minus n minus 1 x minus 1 by n plus 1 into n plus 2. That equal to, here plus and minus n will be cancelled, minus 1 whole power minus 1 x power minus 1 by n plus 1 into n plus 2. Then that equal to, here n plus 2 by n plus 1 into minus 1 into x, then that equal to n plus 2 by n plus 1, n plus 2 by n plus 1 into 1 by x we get. By ratio test, u n by un plus 1, that is limit n tends to infinity, limit n tends to infinity, n plus 2 by n plus 1 into 1 by x, that equal to, here we take common of n, 1 plus 2 by n, 1 plus 1 by n into 1 by x. Here n cancel, then limit n tends to infinity, we take limit, then we get 1 by x. Here it is fails to explain. If it is less, then it is diverges. If it is greater, then it is converges. Then we will take, let if x equal to 1, if we take x equal to minus 1, then the summation un equal to minus 1 by n plus 1. We take mod un for the positive values 1 by n plus 1. Let Vn equal to 1 by n. Limit n tends to infinity, un by Vn by limit comparison test. Limit comparison test, limit n tends to infinity, n by n plus 1, that equal to limit n tends to infinity, 1 by, we taking n to denominator to common the n value, 1 plus 1 by n, that equal to, we get, by substituting limit value, we get 1. Required summation un is converges. Or Vn is diverges. Here the required solution is diverges, at which x minus 1 less than x less than or equal to 1. Here this sum is diverges, but here un is converges, vn is diverges. In limit comparison test depends on vn, so vn is diverges, then un is also diverges, at which minus 1 less than x less than or equal to 1, the given sum is diverges. This is the third sum. Then we go to fourth one. This is the fourth one. This is also form of n. This is also ratio test. We take un and un plus 1. We simplify this problem. This is also same as the norm. This is the required solution is converges, by doing un plus 1 by un. Then we will discuss some. This is also of the form of excess. This is here we take the series first. Different solution we take. Let here given equation x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. This is of the form of sequence. We will write it as let minus 1 whole power n minus 1. It is of the form of x power n by n. Here n is started from 1, 2, 3, 4 and so on. Then let un equal to minus 1 whole power n minus 1 x power n by n. Then un plus 1 equal to minus 1 whole power n minus 1 x power n plus 1 by n plus 1. We take it as formula un by un plus 1. That equal to un is minus 1 whole power n minus 1 x power n by n whole divided by minus 1 whole power n minus 1 x power n plus 1 by n plus 1. Here denominator we take to numerator, then the reverse xn by n into n plus 1 by minus 1 whole power n minus 1. Here plus 1 and minus 1 is cancelled. Then here n reverse it n plus 1 by x power n plus 1. Then here x power n will be cancelled. Then we get only x. Here minus 1 whole power n minus 1 whole power 1 will be cancelled. We require minus 1 whole power minus 1. Here n plus 1 will be here. Then here presents x and also minus 1 whole power 1 into n. That equal to we get n plus 1 by n into x. That equal to 1 plus 1 by n into 1 by x. By ratio test, un limit n tends to infinity by un plus 1. That equal to limit n tends to infinity. Here we require 1 by 1 plus n un by plus value 1 by x. That equal to here we get 1 by x by applying limit value. It is fails to explain. Then if x equal to plus or minus 1, substitute in given 1 minus 1 by x equal to 1 implies 1 by 2 plus 1 by 3 minus 1 by 2 plus and so on. We get it. If x equal to minus 1, we get 1 here minus 1 whole square by 2 plus minus 1 whole cube by 3 minus 1 whole power 4 plus and so on. Here minus 1 whole power 2, it means even number, it becomes positive. 1 minus 1 by 2. Here minus we get 1 by 3 minus 1 by 4 plus and so on. It becomes positive, it becomes negative. Here we take minus form. Plus 1 by 2 plus 1 by 3 plus 1 by 4 plus and so on. We will take. Here it is in ratio test. If the required value is less than, it becomes diverges. Here it is positive value. It means greater than 1. It means greater than 1 means converges. it is diverges. Then the required solution is converges at the value -1 less than x less than or equal to 1. It will be converges. Hence, ratio test verified. Here, we required one converges one and also one diverges one. The required solution converges when at the point -1 is less than x less than or equal to 1. It is converges. Then here some more topics we didn't cover in previous papers. Cauchy's and through test. It is how to find the given sum is Cauchy's and through test is it is powers. Its powers is in n. In ratio test, the given sum is considers all n values, contains all n values. But in here, only power of the values are in n. Next, Cauchy's integral test. It is of the form integration. If we look into that given sum, we point out the given sum is to apply some formula, integration formula. That sum is in the form of Cauchy's integral test. Then alternate series. It is in the form of series or with the -1 whole power some values, some n and -1, etc. like. And also last one, Leibniz. It is we take un less than un plus 1. These type of sums, this is the formula applying for Leibniz rule. It is used in also alternate series and also some also ratio tests. It will be used. These are the topics in sequence and series, but we covered some of sums in previous papers. These are remaining one. In limit comparison test, it is numerator is small, denominator is big, and also second one, rationalize. Third one, sines 1 by n, tan 1 by n, like sums are present there. Next, ratio test, real much ratio test. It is with the n, it contains n values like in the sum. These are the topics in first sequence and series. Up to we complete first half, we have second half, mean value theorem. Don't forget hitting like button and do subscribe my channel and support us and share this video with your friends. Thank you. For more videos, visit my channel.